The cosmos appears infinite with no indication of biological existence. While many of us might assume there is no alien presence beyond our world, nobody can demonstrate the contrary. However, recently, researchers made an astonishingly unexpected finding when examining the second celestial body from our star, Mercury's neighbor. They assert to have discovered biological activity. But how is it conceivable that we haven't identified existence before on this scorching planet until recently? And does biological activity truly exist on Mercury's twin? This neighboring world is an extremely heated sphere, but studies appear to indicate it previously possessed extensive water bodies. It's conceivable that this planet could have been as livable as our homeworld. But in the previous 1,000 million years, heat-trapping gases transformed the sphere from a paradise to the uninhabitable inferno it has become. The burned surface becoming too severe for organisms that may have withdrawn deep underground or into the atmospheric layers to prevent extinction. In order for us to examine the potential for existence on this sphere, it's fascinating to understand a little about this world and its developmental past. Chances are you've observed this planet numerous times without recognizing it. You can effortlessly spot it from our home because it's the most luminous object in the heavens next to our star and our natural satellite. And it's apparent as a brilliant star in the dawn and dusk sky. It's one of only 4 rocky planets in our stellar system and regarded as our planet's sibling world. This neighboring sphere is about 20% smaller than our home, and is more compact inside with an iron center 2,400 miles across. We cannot observe the surface of this planet from our world because it is shrouded with dense atmospheric layers. But there have been space expeditions that reveal it's covered with peaks, volcanic formations, impact sites, and enormous molten rock plains. And for clarification, those spacecraft didn't survive long. This is because temperatures on this world are heated enough to liquefy lead at around 880 degrees Fahrenheit. Hot enough the terrain would radiate a dim red glow. The atmospheric force at the surface is 92 times the ocean level pressure on our planet, or equivalent to being 3,000 feet beneath water. It would compress you, and really, any exploration vehicle not constructed to resist the tremendous pressure. The thick atmospheric layers are primarily carbon dioxide, but also contain a layer of reflective sulfuric acid with the odor of spoiled eggs. It's not a location you would desire to be, or could survive more than a few moments. This world is too near to our star to maintain existence as we understand it, and averages a distance of about 67 million miles away from our star. However, about 3 billion years past, our star was only 80% as bright as it is currently. With that consideration, it's possible that this hellish sphere could have had an environment much like our homeworld. And for about 2 to 3 billion years after the sphere formed, existence could have had sufficient time to develop. The Pioneer exploration spacecraft launched by the American Space Agency in 1978 and several other space investigations have helped us study this planet and reveal some details on how it transformed from an Earth-like sphere to the hellish place it has become today. Evidence was discovered showing there may have been shallow water bodies on the surface of this world for 2 to 3 billion years, and temperatures on the sphere would have ranged from a low of 68 degrees Fahrenheit to a high of 122 degrees Fahrenheit. It would have been simple for existence to thrive under these conditions, and where there is water there is a good possibility of biological activity. Ancient times on this world were certainly much different than it is now, and it's been theorized that it formed from components similar to our home, but followed a different evolutionary pathway. Its rotation rate around our star is 117 days compared to our planet's 1 day. But scientists state it's possible this world once had the same rotational period as our home. It had more arid land than our planet, especially in the tropical regions, and the surface was ideal for making the sphere habitable with abundant water to support an abundance of existence, and there was plenty of land to reduce the sphere's sensitivity to our star. But around 700 million years ago, some kind of massive surface renewal event triggered a runaway heating effect, causing the sphere's atmosphere to become very dense and very hot. No one knows for certain what caused this massive catastrophe to occur, but some researchers believe that volcanic activity may have been the cause, as magma and molten rock bubbled to the sphere's surface, releasing huge amounts of carbon dioxide trapped in the sphere's crust when it rapidly cooled after forming about 4.2 billion years ago. This sounds like a frightening occurrence and, well, similar events have happened here on our homeworld. The Siberian Traps is a huge 3 million square mile region of volcanic rock in northern Russia. It's the evidence of a massive eruptive event that happened in the last 500 million years. The 2 million year eruption released toxic amounts of greenhouse gases and caused a mass extinction. So, now that we know quite a bit about this neighboring world, could simple organisms be struggling to survive on the sphere after millions of years? And how would we know? Recently, scientists state they've discovered a chemical called phosphine in the atmospheric layers of this scorching planet. Phosphine is composed of 1 atom of phosphorus and 3 atoms of hydrogen. It's also being detected here on our homeworld, on the gas giant and its ringed neighbor. So, how is this discovery of phosphine evidence for biological activity? The one thing that got researchers excited about the smelly flammable gas is that, as far as we know, phosphine is present in the clouds of Venus, our closest planetary neighbor. Phosphine can only be made by biological processes, whether it be humans or microbes. Humans have made it to use as a poisonous chemical weapon that was used in the First World War, and, well, it's still made as an agricultural fumigant. But the interesting thing is that phosphine is also made naturally by some species of anaerobic bacteria. These are organisms that survive in oxygen-deprived environments such as waste sites and wetlands. With that in mind, researchers set out looking for phosphine on other worlds, since finding it could indicate the presence of alien metabolism, and they found it in the atmospheric layers of this scorching sphere. Using the largest astronomical telescope in the world, the James Clerk Maxwell Telescope, and the Atacama Large Millimeter Array Telescope, researchers measured trace gases in the atmosphere. The discovery and subsequent papers were explicit that they did not constitute evidence for life, only of phosphine. Phosphine should not be in this world's atmosphere at all. It's extremely difficult to produce, and the chemicals in the atmospheric layers should destroy the molecules before it can accumulate in amounts large enough to be observed. So, what could be creating the phosphine? Some scientists say it's too early to conclude biological activity does exist on this sphere, and that the data needs to be verified, and the phosphine fingerprint could be a false signal introduced by the telescopes or data processing. So could this be the very first planet we actually colonize? It's a question that's been on the minds of scientists and dreamers alike for decades. As we look out into the vastness of space, we're constantly searching for worlds that could one day become a new home for humanity. Near the middle of the atmospheric layer, temperatures and pressures are almost, well, Earth-like. There are even molecules floating around in the sphere's air that alien microbes could potentially metabolize. The possibility of finding bacterial existence in the atmospheric layers of this world is pretty important because, the earliest evidence of biological activity on our own planet comes from fossilized mats of cyanobacteria. These are called stromatolites in northern territories, and they're, around 3.7 billion years old. But honestly, the fact that existence could live in such extreme environments is something we already know about. Around 4 billion years ago, there lived a microbe called the last universal common ancestor, or LUCA. There's evidence that this microbe lived a kind of alien lifestyle, since it was hidden deep in underground iron sulfuric hydrothermal vents, being both anaerobic and autotrophic. It didn't breathe air, and made its own food from the dark, metal-rich environment it thrived in. This microbe's metabolism depended on hydrogen, carbon dioxide, and nitrogen, which it turned into organic compounds such as ammonia. The most remarkable thing of all was this tiny organism, which was really the beginning of a long lineage that covers all biological activity on our homeworld. Now that the biosignature of phosphine gas has been discovered in the atmospheric layers of this scorching world, there are actually missions being planned by several institutions. That even includes California's Rocket Lab, who, by the way, plan to send a spacecraft to this world in 2023 to hunt for definitive signs of biological activity. The mission will use two pieces of Rocket Lab hardware, the 57-foot-tall Electron booster, which is currently used to launch small satellites into space, and the Photon satellite bus, which, recently made its debut flight. The Photon will launch atop the Electron booster, then it'll make its way to this world on a flyby trajectory. When the Photon gets close enough, it'll deploy a probe right into the atmosphere. Its goal? To hunt for signs of biological activity in the deck of air that's actually habitable. But before the mission, everyone will get a chance to see the Electron and Photon in action, as it's booked to take an American Space Agency satellite to our natural satellite in early 2021. And speaking of the American Space Agency going to this scorching world, they have 4 finalists for the next round of Discovery missions. 2 of these newly announced finalists are targeting this world. One of these is the Da Vinci Plus mission, which would send a probe down through the thick atmosphere while gathering data on the way. The second is the Veritas mission, which is set to map the surface in detail from orbit. The probe's observations would help show the sphere's geological history, and could confirm if volcanism and plate tectonics are active on the sphere today. It seems there's no other place in the cosmos with a dense atmosphere. Mountains, sand dunes, plains, lakes, rivers, and oceans except our homeworld. But it turns out there's actually a place much like our home in our stellar system that has a complex weather cycle. Landscapes carved by liquid and volcanic activity. It may even resemble our planet in its earlier stages, and some scientists think it might be better to colonize it first instead of the red planet. This is the ringed planet's moon, called Titan. Recently something bizarre was found hidden in its orange atmospheric layers, and because of this, the American Space Agency is now planning a mission to Titan. But what did they find, and why was it so important? Before we get to that, let's learn a little about this strange world that orbits the ringed giant. Our stellar system is home to more than 150 natural satellites, but only 4 of those have an atmosphere. One of those is Titan, the second largest natural satellite in our stellar system and the largest moon of the ringed planet. Titan is also the only place in the stellar system other than our homeworld that has liquids on its surface. It has a weather cycle much like ours, but has atmospheric layers that rain frozen liquid methane and ethane instead of water. Titan could be the best place for human colonization. In fact, the conditions are right for a self-sustaining long-term human settlement. The ringed planet's moon is a remarkably Earth-like world that has a thick atmosphere, about 4 times as thick as our homes. The atmospheric pressure is about 60% greater than on our planet. Imagine swimming 50 feet underwater to give you an idea. This means you wouldn't have to wear a bulky pressurization suit if you were walking around on the surface. The atmosphere would also keep out deadly radiation, energetic particles from our star, and galactic cosmic rays from making it to the surface of Titan, making it a safe environment for humans. The red planet doesn't have such protection. People living on Titan could walk or bounce around since gravity is only 14% of our homes. If you strapped some wings on yourself, you could literally fly around under your own power. But it's very cold on Titan, because on average it's 886 million miles from our star. You would need a suit to keep warm, because the surface temperature is about minus 290 degrees Fahrenheit, and the only starlight that reaches its surface is like late sunsets on our world. Of course, you'd also need to wear a respirator to breathe. Titan is tidally locked to the ringed planet, meaning one side always faces the giant. It's 759,000 miles away from the ringed world, and has a radius of about 1,600 miles. It takes Titan 15 days and 22 hours to make a full orbit of the ringed planet, and 29 Earth years to make a complete orbit around our star. No one is certain what Titan looks like under the surface, but on January 14, 2005, the European Space Agency's robotic lander, Huygens, made a dramatic descent through the moon's orange smoggy atmosphere and landed on the surface of the natural satellite. The camera on Huygens shows a desolate-looking surface, and it captured that trademark yellow haze which, revealed these intricate details of the atmosphere's layers, winds, and some really mysterious chemical processes. Based on data from the Cassini-Huygens mission, Titan actually has 5 primary layers of rock. This soggy moon has a core made of water-bearing silicate rock, and that's surrounded by a shell of special water ice called Ice 6, which, by the way, is found only at extremely high pressures. Now this high-pressure ice is surrounded by a layer of salty liquid, and then there's an outer crust of water ice sitting on top of all that. The surface itself is coated with organic molecules that have rained down or settled out of the atmosphere, showing up in the forms of sand and liquids. The presence of lakes and seas on Titan brings up an interesting question. Could there possibly be any forms of biological activity there? In 2005, scientists at the Southwestern Research Institute in Texas and Washington State University said that several of the crucial elements for existence on our home are also on Titan, even though the conditions are far harsher than our world. Some organisms are much tougher and stranger than we think. Take for instance, Deinococcus radiodurans bacteria, an extremophile that was in outer space for 3 years outside of the International Space Station, enduring microgravity, harsh ultraviolet radiation, temperatures near absolute zero, and still managed to survive. If there's biological activity on Titan, it could be hidden underground and much weirder than we think. The Cassini spacecraft revealed that the natural satellite is hiding an underground ocean of liquid water mixed with salts and ammonia. Titan could potentially have environments with conditions suitable for existence as we know it in the subsurface ocean, or bizarre alien biological activity that we don't know about yet in a hydrocarbon liquid on the surface. But what happened there recently that drew our attention there? In 2016, a team of scientists identified a molecule called cyclopropenolidine, C3H2, in Titan's atmosphere that's never been detected anywhere else except deep space. The discovery was made using the Atacama Large Millimeter Array, ALMA, that's made up of 66 radio antennas. These all work together, creating a single giant telescope. ALMA uses a technique known as interferometry, where all antennas are pointed in the same point in the sky. The antennas pick up a signal from the target in the cosmos and join forces to analyze the signal. By combining radio waves from the antennas using a supercomputer, researchers can obtain extremely high precision images. In order for ALMA to get these images, there must be a perfect synchronization between all 66 antennas and the electronics with the precision of a millionth of a second. Using this incredible technology, researchers found something they didn't expect to find. So, there's this weird molecule called cyclopropenolidine or C3H2. It's a really strange organic molecule that, well, doesn't exist naturally on our home and can only be seen in a laboratory. C3H2 was first discovered in clouds of gas and dust throughout the galaxy, including the Taurus molecular cloud. This simple carbon-based molecule might actually be a precursor to more complex compounds. And, it could form or even feed possible biological activity on Titan, kind of like the organic molecules that formed existence on our home between 3.5 and 3.9 billion years ago. C3H2 is the only other cyclic or closed-loop molecule besides benzene to have been found in Titan's atmosphere so far. Closed-loop molecules like it are important because they form the backbone rings for the nucleic bases of DNA and RNA, which is also a critical compound for biological activity's functions. However, C3H2 is not known to be used in any modern-day biological reactions. The American Space Agency says the molecule could be an indicator for biological activity since, well, something has to be generating an unstable molecule. If there is existence on Titan, it would be incredibly different from the water-based organisms we know of. NASA has confirmed its Dragonfly rotorcraft mission to Saturn's organic-rich moon Titan, and has a targeted launch period from July 5, 2028 to July 25, 2028 on a SpaceX Falcon Heavy rocket. NASA's pioneering Dragonfly mission has passed its critical design review, keeping it on track for a 2028 launch. It's going to take 9 years for it to reach Titan, arriving in 2037, and will cost a total of $1 billion, including its ride into space. The Dragonfly is a very unique spacecraft design, and is much like a large quadcopter drone, with 2 rotors on each of the spacecraft's 4 corners, hence the name Dragonfly. When it arrives at Titan in the year 2037, it'll need to travel to different areas for study. The Mars Curiosity rover used special tracks to roam the red planet, but with Dragonfly, scientists decided to take advantage of the natural satellite's low gravity with a flying vehicle. This will be the first time that the American Space Agency will fly a multi-rotor spacecraft for science, and Dragonfly will be able to make vertical takeoffs and landings. Despite the lower gravity on Titan, it still needs electricity to fly around. So the Dragonfly is equipped with a radioisotope thermoelectric generator, a type of nuclear battery that converts heat from decaying plutonium-238 into electricity. This means it could fly and operate on Titan for decades. Since Dragonfly can easily fly around, it can be moved so that it's always facing our home for direct communication, which takes 70 to 90 minutes each way, since Titan is so far away from our world. During its proposed 2.7-year mission, Dragonfly will take advantage of the dense atmosphere that will keep cosmic rays and radiation from destroying it, and it will fly to many different locations to pick up surface materials for chemistry experiments. It will also check out the natural satellite to see if it's possible for humans to inhabit it one day. Since the building blocks of biological activity or the organic molecules on Titan are expected to be similar to those on our home before existence arose, Dragonfly will help study how far pre-biological chemistry has progressed to see how existence evolved on our own world. See, we have no idea how biological activity really formed and began on our sphere. All we know is that it involved organic molecules. Dragonfly will check out the natural satellite's atmosphere, what the surface is made of, and the ocean that lays below the surface, looking for complex organic materials that are the keys to biological activity. Now the only thing left is to build the spacecraft and get it ready to launch. Even if we don't find what we're expecting there, the Dragonfly mission will show us much more about Titan. It seems that we may soon find existence on another sphere or natural satellite, and that'll be a very exciting time for science and humanity. The gas giant's biggest natural satellites were discovered 400 years ago by Galileo. Io, Europa, Ganymede and Callisto are fascinating worlds, and some could hide oceans that could hold biological activity. Now, the American Space Agency claims that the Juno spacecraft has detected an FM radio signal coming from one of these giant natural satellites. Where did this signal come from? How did the agency find it? And what other secrets are the gas giant's other natural satellites hiding? So, we saw your comments about wanting to hear more about the strange FM signal coming from one of the gas giant's natural satellites, and now we've delivered just for you. Enjoy. Something recently happened that caught everyone's attention. The American Space Agency's Juno spacecraft is still out there wandering space, and for the first time since it was launched, it picked up an FM radio signal coming from the gas giant's natural satellite Ganymede. This is the same kind of signal that you would find here on our home. In fact, we use this signal every day and know it as Wi-Fi. Did we just pick up an alien radio station broadcast from Ganymede? To figure that out, we need to know more about this icy alien world. Ganymede is the largest natural satellite in the entire stellar system. If it was orbiting our star, it would be a sphere itself, being larger than Mercury. Although Ganymede doesn't have an atmosphere, it's the only known natural satellite to have a powerful magnetosphere, which sometimes produces auroras that are affected by the natural satellite's underground saltwater oceans. The rocking seen by the auroras gives researchers evidence that the underground oceans on Ganymede are possibly liquid and very salty, far saltier than our home's oceans. So, the FM signal that came from Ganymede actually originated from electrons in electromagnetic fields, a process that, causes the electrons to whirl and oscillate much slower than their spin rate. The Juno spacecraft detected this 5-second radio burst in late 2020 when the natural satellite crossed a polar region of the gas giant where the giant's magnetic field interacts with Ganymede. So, could there be biological activity on Ganymede? Well, we know for sure the signal didn't originate from alien existence. It's also very cold on Ganymede with temperatures around -186 degrees Fahrenheit. However, during one of its flybys, the Galileo spacecraft detected a dense stream of atomic hydrogen, escaping from the natural satellite's very thin atmosphere. This means that there are large amounts of oxygen that's locked up or hovering over its icy surface. The hydrogen is the lightest atom, and Ganymede has a weak gravitational field, so the hydrogen escapes and the atomic oxygen stays behind. Some researchers say that Ganymede could have as much oxygen on its icy surface as our home has in its atmosphere, so could Ganymede have everything for biological activity to exist in its subsurface oceans. Some scientists think the pressure at the base of any ocean here would be so high that it would turn to ice, but a mission is needed to find out more. But this natural satellite isn't the best candidate for existence. In fact, there is another natural satellite orbiting the gas giant that some scientists are calling the most habitable place inside our stellar system. Europa is an icy white natural satellite with brownish streaks on its surface, and has an icy crust that could be from 2 to 20 miles thick. It's the smoothest surface of any other object in our stellar system, and you wouldn't find any mountains or craters here. Underneath the icy surface would be a vast underground saltwater ocean, which could be twice the volume of those on our home. Europa is very cold with an average temperature of -260 degrees Fahrenheit, which keeps the icy crust as hard as granite. But could biological activity still exist here? It's possible. At the dawn of the space age, it was thought that all existence depended on our star, and any object too far from a star would be a frozen ball of ice unable to support biological activity. But finding thriving ecosystems at the bottom of our home's oceans, relying on hydrothermal vents, changed all that. Now we know existence is pretty tough, and it can survive completely isolated from the energy of a host star like our Sun. It's important to know this because Europa could harbor simple microbial existence in liquid oceans underneath its icy crust. And this biological activity could be surviving off the same kind of hydrothermal vents. So how do we know that Europa probably has liquid water needed for existence to thrive? The Galileo spacecraft that flew over the natural satellite in the 90s uncovered evidence of a vast, deep, dark, global subsurface ocean. Even though the natural satellite should be a solid ball of ice, the water on Europa doesn't freeze completely because it's constantly churned by powerful tidal forces as the natural satellite orbits around the gas giant, and at the same time those tidal forces cause Europa's core to generate heat. Scientists are excited because this global ocean is thought to be in direct contact with surface ice and the natural satellite's silicate mantle. This brings together everything needed for a habitable environment: liquid water, a source of energy, and a source of minerals and nutrients that biological activity needs to flourish and survive. We know some bacteria or extremophiles like tardigrades can survive extreme environments, and just maybe Europa's hidden ocean could have these kinds of organisms. Between 2014 and 2016, researchers got evidence that there might be liquid water on Europa. Hubble Space Telescopic images showed evidence of huge geysers of water vapor, some 62 miles high, erupting from the surface over Europa's south pole. Although some researchers aren't sure, we're going to find out soon enough. The American Space Agency wants to send a probe to Europa by 2025. The spacecraft is called the Europa Clipper, and it will explore whether this icy natural satellite has conditions suitable for biological activity or not. The $2 billion solar-powered probe will fly by Europa 40 to 45 times using a number of high-tech instruments to study the natural satellite's icy shell and the ocean that's underneath the surface. Whether it finds existence, Only time will tell. And what about the gas giant's natural satellite, Callisto? Is it possible biological activity could exist there as well? Callisto is the second largest gas giant natural satellite and the third largest natural satellite in the stellar system. It's almost the exact same size as Mercury, but with a surface temperature of -218 degrees Fahrenheit. It was once thought to be a dead natural satellite because of its ancient cratered surface. In fact, it has more craters on its surface than any other object in our stellar system. If you have many craters on the surface of any astronomical object, it means that geological processes are probably dead. But Callisto also orbits too far away from the gas giant to be affected by the giant's magnetosphere and heavy gravity. However, Callisto may also have an underground ocean, and the satellite's icy crust might be acting like a cosmic blanket, insulating this underground ocean. It's not clear whether this ocean could hold biological activity because the surface is so old. The only way to find out for sure what's happening on these icy natural satellites is to send a probe. The American Space Agency and the European Space Agency are building the gas giant Icy Natural Satellites Explorer, or JUICE, which is planned to launch sometime in 2022 and begin a 7.6-year cruise to the gas giant, arriving sometime in 2029. We've all heard about the James Webb Space Telescope and the amazing potential it will have to find habitable exoplanets. But the JUICE probe is going to be carrying the most powerful scientific payload ever flown to the outer stellar system, which includes 10 state-of-the-art instruments, plus will perform an experiment using the spacecraft telecommunication system with ground-based instruments. During the first part of its 3.5-year mission, the JUICE probe will make 30 observation overflights of the 3 icy natural satellites, Callisto, Europa, and Ganymede, studying them in close detail by examining their gravity, magnetic interactions, and checking to see if liquid water really does exist under the surface of each one. It'll then investigate whether these oceans might hold the organic components necessary for biological activity, or even, existence itself. There's another interesting natural satellite that's been grabbing the attention of researchers lately, but it's not in the gas giant's orbit. However, we think it's worth mentioning if we're going to talk about finding existence in the stellar system. In 2019, the American Space Agency revealed the ocean on the ringed planet's natural satellite Enceladus contains the building blocks for biological activity. This vast water ocean is about 6 miles deep and lies under an icy crust that's 19 to 25 miles thick. Images of huge plumes of water vapor erupting through cracks at the south pole of Enceladus were captured by the Cassini spacecraft and indicate there must be an underground ocean. These plumes were analyzed by the folks at the American Space Agency and found to contain water vapor, ice, salts, methane, along with simple and complex organic molecules, the kind of stuff normally found in living systems. The newest study of Enceladus shows the natural satellite is more geochemically complex than previously thought, and that carbon dioxide is being controlled by chemical reactions on the seafloor of an interior ocean, boosting the chances of the natural satellite having some kind of biological activity. On our home, oxygen-breathing creatures consume energy and organic matter like glucose and oxygen to create carbon dioxide, and water and oxygen-breathing microbes can metabolize hydrogen to create methane. So, the American Space Agency's Cassini's ion and neutral mass spectrometer detected methane, carbon dioxide, ammonia, molecular nitrogen, and molecular hydrogen in the plumes. And, molecular hydrogen would indicate there is free energy available in the oceans of Enceladus. Cracks in the ice where the plumes erupt have temperatures warm enough that seems to show the ocean is being heated by the natural satellite's core. These hydrothermal vents could be similar as the ones found on our home's oceans and a hotspot for biological activity. A team of scientists now want to send a probe to the natural satellite to find out. It's called Orbilander, which would cost $2.5 billion. The probe would orbit Enceladus for 200 days, which won't be easy considering the ringed planet's giant gravity field. Orbilander will fly through these plumes of vapor, which will then funnel into science instruments at high speeds. But this probe won't only orbit the natural satellite, it'll also land on the surface. And so it will need to find the perfect place. Once the location is found, the probe will convert to a lander. 2 nuclear power sources will keep Orbalander running on the surface of the natural satellite for up to a year and a half, while it sends data on what it finds back to our home. Another big achievement of MOXIE is that it's the first kind of technology that just used elements of another world's environment and turned it into a usable resource. The American Space Agency calls it in situ resource utilization. Oxygen is also needed for rockets, and to get off the red planet, a ship or rocket would need about 33 to 55 tons of fuel. That's where liquid oxygen comes in. The red planet-made liquid oxygen could supply more than 3/4 of the fuel needed to explore the red world, and could also fuel other missions to nearby spheres and natural satellites. And if you mix hydrogen and oxygen together, you either produce water or hydrogen peroxide. And water is another important resource that we're going to need. 3 billion years ago, an ocean covered 1/3 of the Martian surface, but now, 99% of the red planet's water is ice. It should be possible to melt this ice and filter it so that it can be used. When it comes to colonizing the red planet, we could build big domes and pressurize those with a breathable atmosphere using a MOXIE system. But building domes and living inside them is no easy task, and we need to be sure we're up for that challenge. Take for instance the Biosphere project, which was a compound built in Arizona, to see if we humans are able to build and live in self-sustaining colonies in outer space. We have a more in-depth video on the Biosphere project you can check out. Thanks to this project, we now probably understand exactly what we need to build these domes out of, and how we might be able to survive inside of them. Technology has come a long way since then, and Elon Musk says that we would live in big domes made of glass at first, and then we'd eventually terraform the sphere over. Humanity will definitely colonize Mars and other planets. It's just a matter of time and money. Subscribe to the channel and follow the news of science and the secrets of the universe on Enigma Horizon.